Homework 2.2, more on functions, optional video 11. If you're watching this video, then chances are you are in my college algebra class right now, but you know that at some point in the future you're going to take a calculus class. And in the previous video, I should have mentioned that that includes business calculus. So this one's going to be a little bit more technical, but I really want to illustrate the usefulness of difference quotients in a calculus context. I want to remind you of a few things before we start though. Number one, the genesis of difference quotient was to calculate the slope of a line connecting 2 points on any graph, where the first point's x-coordinate was generically represented with x, but the second one was represented with x plus h, where h represented the distance between the 2 points. Secondly, in the previous video, we calculated the difference quotient for f of x equals x squared plus 2x plus 3, and its difference quotient was 2x plus h plus 2, which geometrically represented the slope connecting a generic point. Let me say that again. Third time, the difference quotient represents an expression for the slope of a generic line connecting a generic point and a generic second point, where the second point is described by how far over it is from the first point. So what does this mean in terms of calculus? Well, let's say for a moment that we're on this parabola, the graph of that function, and we're back here at x equals -2. So this point is above x equals -2. In calculus, one of the big generic questions you attempt to answer before you use it for applications is, what is the slope of a tangent line to a graph? In other words, if we were to draw a line that just barely brushed up against this point above x equals -2, what is its slope? It's an attempt to measure the slope of something that's not a straight line, because as you move along the graph, the tangent line would change. The problem with trying to find the slope of a tangent line is that it only touches one point on the graph, but the slope formula requires 2 points. So the calculus approach is to do this. You pick one point and you leave it fixed, so here at -2. But then you pick another generic point off to the right by describing it as move it over h units to the right. Then you come up with an expression for that slope, which we have there. And here's where the calculus comes into place. Calculus is about letting things approach other things. It's a really rigorous definition. But the premise here is, let's leave this point alone and let's let this point slide closer to it. So if we slide it down, we get a line that looks like that. If we slide it down here, we get a line that looks like that. If we slide it down here, we get a line that looks like that. And what's happening to this red line as this point is sliding is that it is rotating, and as the second point gets closer, the red line rotates closer and closer to the green line. Will it ever be the green line? Sure, when this point merges with that one. In other words, when the distance between them is 0. So how can we use this in a calculus context? If we want to find the slope of f of x at x equals -2, then we have to ask ourselves what would happen as the second point collapses to the first one and these red lines slowly merge into the green line. Well, I know what x value I want to use, -2. But what is happening to this h value as the 2 points converge? In other words, as this second point slides closer to the first point, what is happening to the distance between them? The answer, it's approaching 0. It never technically equals 0, because you can't have 0 in the bottom of a fraction, but it approaches 0. So the slope at x equals -2 as h approaches 0 is whatever the difference quotient is. Now I'm going to break the rules a little bit. I'm actually going to put in 0 for the h, and I'm going to put in -2 for the x. The -2 for the x is okay, but this is where the calculus gets persnickety. The h is approaching 0. That doesn't mean I can substitute 0 for the h, but there are conditions under which you can, and this particular function happens to satisfy that particular condition. So we put in -2 representing the x-coordinate of the point where we're trying to find the slope of the graph, for the -2 for the x, and put in 0 for the h, which represents the second point's distance from the first point collapsing to 0, and hence the 2 points converging to each other. So 2 times -2 plus 0 plus 2. 2 times -2 is -4, plus 0 is -4, plus 2 is -2. The slope of that green line is -2. Now, for those going to calculus, I will tell you that there's a much quicker way to get from here to here. In fact, it is so quick that when you learn it, you can actually go, I know the answer, it's -2, and totally bypass the difference quotient. Because you will do the difference quotient and then figure out a shortcut to it. And when you get to the shortcut, calculus suddenly becomes a lot easier. So for those of you heading towards calculus, you will see difference quotient early, along with something called a limit. But let me tell you this about calculus. Every student should know this before they go into calculus. It starts out a beast because you see all these things that you've never seen before. Visually, they're easy to wrap your mind around, but symbolically, they're a mess. And then things get real ugly, and it stays that way for about the first chapter. But once you get past the first chapter, and you start learning how to do these difference quotient problems almost instantaneously, you learn some rules, then calculus suddenly becomes a lot easier. So for those of you heading towards calculus, it's a pain until you get past the first test. Then you learn some shortcuts, things suddenly become easier. I'm not going to say that everything is easy, but once you get to those shortcuts, the difficulty in calculus lies in algebra and trigonometry. So before taking calculus, make sure you got a strong algebra foundation and a strong trigonometry foundation. Start calculus, things are ugly for a couple of weeks, 2 or 3 weeks, you take your first test, grade probably sucks. Then you learn shortcuts and suddenly things start becoming easier, provided the algebra and trig skills are there.